The next speaker is Hatice Sözer, Turkish University, after education in, amongst others, Illinois and Colorado. Not about Turkish earthquakes, also, although that would also be a nice item, but about integrated renewable systems in buildings. So we're moving up in the building. Hatice Sözer, please, the floor is yours.
Good morning. Actually, Turkish pronunciation of my name, Hatice Sözer. Today I'm going to talk about identification of barriers to building integrated renewable system. I'm going to use the PV system as renewable system in my presentation. High-rise development in Turkey growing incredibly fast, especially for the last 10 years. One of the tallest buildings today is the building called Sapphire. It has the 54 stories, and its height is 261 meters. This image taken from Sapphire, in the Turkish, when when we look at the Sapphire, if we compare the Sapphire with other cities' tall building design, for example, Burj Dubai, Burj Khalifa in Dubai, it has the height of 828 meter height, or the Sears Tower in Chicago, it has the 450 meters height, which was constructed 37 years ago. Sapphire may not be considered as the list of tallest building in the world, but the concept of Turkish architecture and its height distinctly the higher than urban norms, as you can see. I'm sorry, from in this image. Considering the existing technology in the building, construction technology, all these high-rise developments also brought a new perspective to Turkish architecture. All these, the tall buildings you see along with this road is constructed for last 10 years, and because of these new developments here, this region becoming the business districts now in Istanbul, financial and business district in Istanbul. This is the list of the highest, first 30 highest building in Turkey. The Sapphire is the first one, of course, and until residentials. As I said, most of this building constructed in Istanbul. It also has the 54 story, but its height is 210 meters. And there is another one. It's in the same region with the Sapphire buildings. It has the height of 181 story height. Another one, it's the constructed. It's not in Istanbul, outside of the Istanbul city called Mersin. It's represent the early the construction of towers in Turkey. Another one also constructed in another city called Konya. It constructed at 2008. And Trump has its towers in Istanbul. Its construction completed in 2010. And we have tall building towers also in Ankara, Sheraton. It's also represent early early the tall buildings design. It has the 143 meters height. Most of these high-rise buildings has certain energy-efficient strategies in their design, but integration of photovoltaic system into the building as a building material has not been clearly defined in any of these buildings yet. In Turkey, when we look at the world, there are so many countries that has PV integrated photovoltaic systems, buildings. For example, for Times Square buildings in New York is the very early example of a PV integrated photovoltaic system. But still, the concept of PV integration into the building and its design process has not been clearly defined yet. Actually, challenge for this kind of design is how to integrate the tall building concept with the PV and make this concept easily applicable for the construction industry and spirit this promising technology for the user. This is the solar potential in Turkey. If you compare this with the rest of the Turkey's neighbors country, we can easily see that Turkey has better solar potential than rest of European countries, which most of them has very good and important PV integrated building. And as Edison stated in 1932, sooner or later we shall have to go directly to the sun for our major supply of power. Today we have the technology of PV to take advantage of photovoltaic, take advantage of solar, but the question is how we can integrate architecture and this technology together and make it part of our building design. There are other the issues such as social and aesthetic issues, cost, energy and environmental issues related with this the integration, and to be able to make create an intelligent and adaptable architectural solution, we have to work with all these issues. And now I'm going to identify what is the architectural building design concept, but before I go into that, I'm also going to identify what are the barriers that we have to face before we go to architectural design process. Our main goal when we integrate the PV into our facade to produce productive mode buildings, which means buildings that will going to produce its own electricity when we integrate the PV. But other than that, once we integrate the PV into the building as a building material, the PV should act as part of building material. The PV curtain wall system that we are going to apply has to be equivalent to traditional curtain wall systems. The barrier that we face before we go into the building design process, especially in Turkey now, one of the important one is the market barrier. It comes with first one is the consumers. One of the important one is the lack of early adoption of PV curtain wall system in Turkey, which create unrecognized expectation from the customers. Of course, economic barriers is one of the major one because it has the very high capital cost. Procurement is also another one because we have a lack of infrastructure, such as there is no local dealer right now. Technological development is one of the important one. Of course, also the system is not reliable for today's technology, and we don't have any standardization for this kind of system yet. We have to face with the institutional barrier. There is no code and standard for this technology yet, and the public awareness of this one, and there is no public awareness, and utility policy and business practice is not clearly clarified yet. This is architectural building design process, barrier that we have to face during this process, the lack of interface, lack of common language, mismatched potential, unknown performance, and lack of economic analysis. What is the building design, architectural building design process is it starts with the conceptual design, continue with design development, and with construction, the documentation phase. During the construction, concept design, architects brings all this data about the building specifications and decide try to produce different design alternatives. And all this information and the ideas about the project works concurrently on many different levels. During this process, each phase has reflected each other. One phase never ends when next phase started. Whenever we integrate new technologies such as photovoltaic system into the design, all this system data architect brings all this system data as well as building specification. So during the conceptual design, architects makes decision about set the building strategies. So conceptual design phase, it's very important one. And when it comes to the design development phase, the architects and other engineers, this is the process, it shouldn't be involved just the architects and other building professionals should work together during this. And architect and they start experiencing the integration, PV integration, and with trying different schemes, and this advance their knowledge about the PV integration and PV specification also. And when it comes to the construction documentation phase, they start experimenting the building as it's built with the computer simulation sketches and models. And it is they experiencing the building virtually. So this the doing and reflecting phase continues simultaneously during the design. But architect's job never finish at the end of architectural design process. It goes beyond, because whenever we apply the technology such as PV, it's during the the construction documentation phase, we have to have measurement and verification. Architects has to follow this closely. If we are going to, one of the barriers is the lack of interface. If we are going to integrate the photovoltaic system into our design, the full integration is essential. PV has to be part of our building material system. And it has to fit in the building design process from the beginning. And the building should have standard and codes as part of building material. And it has to be part of the organizational structure, and all these professions involved with the design, they should be aware of all these building PV specifications. And overall, it has to, PV has to match with regular quality scheme for building components. And the curtain wall system, generally, when we look at them, the traditional one are the prefabricated elements integrated with the exterior of the buildings, protective skin, architectural and aesthetic characters, they have architectural and aesthetic character, and it provides the stiffness of the buildings. They can be glass or combination of metal or glass, precasted or stone. The problem, sometimes problem can be when we integrated PV into the building, we have to calculate, define the cost and the power generated from the PV as part of building material. Usually, the PV systems cost and the power generation calculated as building PV system is the single elements. Physical characteristic of the system, the thermal properties and thermal qualities has to match with also with the conventional systems, and life expectancy of the PV curtain wall systems. So today's it has the 20 to 30 years life expectancy. The regular curtain walls is less than regular curtain walls actually. And quality and constructability also should match. And the one of the important aspect is the safety issue because of all this wiring. So there are different the detailing for that. Wiring can be housed in two sides, in the double skins windows, or it can be housed inside of the mullion, and it can be opaque. I'll go quickly, and it can integrate it on the spandrel and or transparent, and these are the different alternatives. There are risks associated with the PV integration. For example, the shading is very important during the lifespan of the building. It can be shade, and another one, lack of knowledge for the building professions, and also the PV technology. It's the improving technology, and the financially making the investment for the PV may create a certain risk. So when we work with the building design process, there is in all these professions, if they work together during the building design process, there are the incredible potential for the cost reduction. And it's it's very important for the building professions, which building profession is going to work in what stage of the development. And another barrier is lack of common language. They have to communicate all these building professions with each other. Another one is mismatched potential. We have to identify clearly what would be the need for the buildings and how much we are going to generate from the photovoltaic panels. And how we can break these barriers. Our goal is to reach the best quality and value, maximize the quality and value, and minimize the cost and time. And as I said earlier, we have to identify each professions and which one is going to involve in what process for each phase building during the building design process. And this is the final phase, and the deliverables of the project should be clearly also defined. Thank you.
Thank you very much, and sorry again for rushing.